In this session 11, we are going to study about distance between two complex numbers. First, let us see how to find distance between two complex numbers. Let us consider two complex numbers, z1 and z2. Let the first complex number be z1 is equal to x1 plus iy1. And let this complex number be represented by a point capital A, that is x1 comma y1. So if you see, this is in the complex number form, but this is in ordinary analytical geometry coordinate system form. It is simply represented in this way, right? In the same way, let us consider the next complex number is z2. Let this be equal to x2 plus iy2, and it is represented by b x2 comma y2. Now let us try to plot this complex number in the organ plane. Right. This is our organ plane, and this is our point A, and this is our point B. This A point is represented by this, and B point is represented by this. Now let us try to find these 2 points. You know very well, distance between any 2 points x1 comma y1 and x2 comma y2 will be simply equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is what we have studied in analytical geometry. The same answer is to be received in complex number view also. So how to get this value? Now if you see, this is simply x2 minus x1, this is y2 minus y1. That is x2 minus x1, y2 minus y1. So real parts are subtracted and imaginary parts are subtracted. So simply this is z2 minus z1. Let us try to find z2 minus z1. So your z2 minus z1 value will be equal to x2 minus x1 plus I into y2 minus y1. Somewhat we are approaching this. Now let us try to find modulus value to this complex number. Its modulus value is square root of real part square plus imaginary part square. So for example, if you want to find modulus to a complex number, you have to find the square root to that complex number by keeping the real part square plus imaginary part square. So if you find modulus to this value, that is real part square, imaginary part square under the square root. So if you see these two, now these two are same. So we know very well this represents distance between 2 points according to coordinate geometry. The same answer we are receiving when we find modulus of z2 minus z1. So if you try to find distance between two complex numbers z1 and z2, it is very simple. Just you have to find modulus of z2 minus z1. So if you want to find distance between any two complex numbers, it is enough for you to find modulus to the difference of the two complex numbers, whether it is modulus of z2 minus z1 or z1 minus z2, both will have the same answer. Right. Now let's try to do a small, very simple sum. Let us find distance between 2 plus I and minus 4 plus 3i. Let us represent the first complex number by z1, and let us consider the second complex number by the name z2. If you want to find distance between these two complex numbers, so we have to find modulus of z2 minus z1 or modulus of z1 minus z2. Both will have the same answer. So now let's try to find z1 minus z2 value. For z1, 2 plus I. For minus, we have placed the minus here. and for z2 minus 4 plus 3i. If we simplify it, your answer will be that is 2 plus I minus into minus plus 4 minus into plus 3i minus 3i. If we simplify this, 2 plus 4 will be 6 and plus I minus 3i, our answer will be minus 2i. So this is what the simplified answer. Now we got z1 minus z2, the complex number. But we have to find the distance between these two complex numbers. So already, as I told you, we have to find modulus to this. So if you find modulus to this, modulus of z1 minus z2 will be equal to real part square plus imaginary part square, that is under the square root. So your answer will be equal to square root of 36 plus 4, that is square root of 40. If we simplify it, we can write the square root of 40 as square root of 4 into 10. For 4, if we take square root, its answer will be 2. So the answer will be 2 into square root of 10. So this is the distance between these two complex numbers, these 2 points. So it's very simple to find distance between two complex numbers. Using this method, we can prove so many things in complex numbers, in the two-dimensional things. Right. First, this is a parallelogram. If we want to prove the given 4 complex numbers forms a parallelogram, it is enough to prove the midpoint of these 2 complex number and midpoint of these 2 complex number are same. That is, very well, in a parallelogram, diagonal bisects each other. So it is enough to prove z1 plus z3 by 2, that is midpoint of these 2 complex numbers, is equal to z2 plus z4 by 2. If we prove this, it is proved. In another way also we can prove it by taking the lengths, because in a parallelogram the opposite sides lengths are equal to one another. So this length is nothing but the distance between these 2 points, that is modulus of z2 minus z1. Similarly, this distance is modulus of z3 minus z2. Similarly, this distance is modulus of z4 minus z3. The same way we can find to this also, that is modulus of z4 minus z1. Now we have to prove these 2 sides are equal to one another and these 2 sides are equal to one another. Moreover, to prove this as a parallelogram, that is, a parallelogram means it may be a square or rectangle or like this. It's okay. Anyhow, if you want to prove this is not a square or not a rectangle, then you have to prove these 2 diagonals are not equal to one another. But anyhow, if you want to simply prove this as a parallelogram, it is enough to prove the opposite sides are equal to one another. There is no need of worrying about the diagonal. But in case if you want to prove this is not this is a parallelogram, but it's not a particular square or particular rectangle, then you have to prove the diagonals are not equal to one another. So to prove a parallelogram is enough for you to prove the midpoints of the 2 diagonals are same, like this. Or you can find the distances or the sides lengths and you can prove like this. It is enough. It is enough to prove this as a parallelogram. In case if you want to prove this parallelogram doesn't form a rectangle or it doesn't form a square, it is a parallelogram but not in with the right angles at any place, then you have to prove using the distance between Z1 and Z3 and Z4 and Z2 are not equal to one another. That is, the diagonals are not equal to one another. But that is not so important, because question may not be like that. Right. Then sometimes you may be trying to prove the given complex numbers forms a right angle triangle. For this, just you find this distance and find this distance, find this distance. So this is your hypotenuse, and if you prove the Pythagoras theorem, it is enough that we have proved the 3 points represents a right angle triangle. That is, hypotenuse square is equal to opposite side square plus adjacent side square. Right. Moreover, sometimes we have to prove this is a square. Then the same logic you can follow. Opposite sides are equal to one another. Since it is square, all the 4 sides will be equal. So all you have to prove for a square, all the 4 sides are equal, and you have to prove these 3 points form a right angle triangle. This is one way. Another way, just you have to prove all the 4 sides are equal and diagonals are equal to one another. In case if you want to prove the given 4 complex numbers forms a rectangle, you have to prove the opposite sides are equal to one another, and you have to prove it forms a right angle triangle. In case if you want to follow some other technique, that also we can follow, that is we have to prove the midpoint of the 2 diagonals are equal to one another like this way. Then we have proved it is a parallelogram. After that, you may prove this as a right angled triangle. These 3 points form a right angled triangle. In this way also we can prove the given 4 points forms a rectangle. Right. In case if you want to prove a triangle, isosceles triangle or triangle, just find the distance between these 2 points and distance between these 2 points and distance between these 2 points. And you have to prove, if you want to prove this as an isosceles triangle, then these 2 sides should be equal to one another. In the same way, for equilateral triangle also you can do and prove all the 3 sides are equal to one another. Sometimes they'll ask you to prove the given points are on a circle, and they'll give you the center. So in case if the points A and B are here, that is on the circumference of the circle, and if they are asking you to prove these points form a circle and keeping this as center, then find just distance from the center to the point A and center to the point B, similarly from the center to point D, like that, whatever the point they are giving you. So if you are able to prove that CA value is equal to CB value and so on, then we have proved the points form a circle by keeping a particular point as its center. So this is a very simple and very easy one, and you can practice more sums from your exercises. Thank you.